So now what we're going to do, we're going to click on sort descending, and now we can clearly see that we have 3 observations having standardized scores which are greater than 2.5. So we have this observation, this one, and this one. 3 observations. We come here, we see what we have those 3 observations. If we go to the variable here, number of interviews attended, c'est la question, so it was question 23.2, here we are. So this respondent actually said that he or she attended 50 interviews, and this one said 25 and this one 20, so this seems to be really exaggerated. 20 interviews, 25 interviews, 50 interviews. Now it could be true, it could also be that those were mistakes, those were actual mistakes in the input or in the data collection itself. Okay, in any case, those are very odd, as we can see here. So here we have been able to detect those outliers. Good. Now let's use the second technique and see how it works. Okay, so that's the z-score technique, as we said. Okay, so that's what we did here. Now let's use the interquartile range technique. Okay, let's use the interquartile range technique. So let's go on now, analyze. So those are the steps. Okay, interquartile range technique, descriptive statistics, and now we click on explore, and we go and look for our variable, and that's number of interviews attended. Here we are, and we select it, and then we want to go on statistics and select percentiles and outliers, and we also want to select here histogram. That gives us a good visual representation of what's happening, and then we click on OK. So now we get our results. Okay, and so here we can see, okay, so we have a look here. Here are our percentiles. So 25th percentile score 1, 75th percentile score 4. Okay, so here we have values which are ranked. So we have again our 3 extreme values here, remember them. If we look at the histogram, we clearly see here that we have those observations, which seems a little bit odd here, especially this one, isn't it? This was what we detected earlier when looking at the standardized score using the z-score technique. So we see it again here, and that's here where SPSS actually indicates the outliers. So you will see here, so using the interquartile range technique, what SPSS has done, so for those who have a star here, it has actually added the 3rd quartile value with 3 times the interquartile range. Okay, and you get those values, okay, actually that's what I should say, those values are greater than the sum of the 3rd quartile plus 3 times the interquartile range. So those are really extreme values, and we have observation number 1 to 3. Now obviously those are 1 to 3 because, as you will recall, we already sorted our data set earlier using the z-score technique. So we have observation 1 to 3, which have been already ranked now in terms of z-scores. So we see that those 3 observations are also detected here as being extreme outliers. So you see, whether using the z-score technique or the interquartile range technique, we come to the same results. Okay, now we need to interpret. So using the z-score technique, as we saw, we have 3 values which are detected as outliers with the observations 1 to 3 with IDs 94, 69 and 34. Using the interquartile range technique, we get the same thing. Okay, so those are the values 94, 69, and 34, which are considered to be outliers, to be extreme outliers. So now we need to take a decision. Okay, now those does seem to be quite unreasonable, so we might consider deleting them. So let's suppose we decide to delete them because those are really unreasonable and we think that those have most likely been entered due to some error in data input or data collection. So then what we want to do is we want to omit those variables, those observations, sorry, when conducting our analysis. So instead of deleting them, an option will be to go on variable view and then indicate them as missing values. That's what we can do. Or you can go just and delete them directly. Okay, so that's another possibility. You can just go here and just simply delete them. So we just can click on delete here, delete here, delete here. Okay, and what would be your preferred choice if you have outliers at both sides, so on the upper side and the lower side as well? That's what you will normally do. But since here we have it on only one side, what you might do, instead of just deleting them, you might go here, you might go to your variable, and then you denote them as missing data. So we say from, so we know that so we have so let me check that again. So 20 to 50. Okay, so 20 to 50 will be considered to be missing. Okay, so if we just compute a descriptive statistics again and we say okay, now we have a maximum of 12. And the mean, as you will see, has really gone down drastically to 3. Okay, and that's a typical example here of huge influence that outliers can have on mean values. So if we took earlier with the outliers included, we had a mean value of 3.9, right? And here it's 3, almost moving from 4 interviews on average to 3 interviews on average. So huge difference, okay, just because of those 3 observations, of the effect of those 3 observations. So you see, it's super important for us to detect outliers. And yeah, so I think it's clear enough in your mind, okay. So how to detect outliers, and you've seen how a huge influence those can have. So it's super important, okay, whenever we are doing quantitative data analysis, to analyze our data properly, take time, and detect those potential influential observations, okay, referred to as outliers. Thank you very much. In future lectures and videos, we might deal. We look at more kind of more advanced technique to deal with outliers. For example, we look at the Mahalanobis D-square technique, which allows us to detect multivariate outliers. Okay, but what are useful when we perform multivariate analysis. Having said that, you always want to first look at univariate outliers and make sure that you have detected them properly. Okay, so cheers, bye bye.